Okay, so starting off on this recording, I'm just walking through a problem similar to one you've seen a lot. It's not the exact same one as your review, so notice here, I'm pretty sure yours says D. This is worksheet D2. So um, this is a different problem, so the numbers are different because of that reason, but it works the same way. I just wanted to show you with it um, on a different problem. One, so you have extra problems to review, and two, so you can watch this and then try the problem in your packet yourself. So to do these, I have given you some steps here because I know you all love steps. So what you can do is just pause the video really quick and write these steps down and then unpause me and we'll get going after that. Okay, so welcome back here. We're going to walk through the steps together because doing this in a step-by-step process makes this a lot easier, especially step 3. You'll see labeling the axis. Before you try to get any points, don't just try to go to points, okay? Make sure you go through the full steps to do this. So first step, read the full prompt and label the picture as you go. So let's do that. The blades of a boat motor rotate in a clockwise direction and complete 60 rotations every second. 60 rotations every second. So this is always telling me like how long it takes to go around. That's talking about the period. But notice here, this is not the period exactly. It says I go 60 rotations every second. And a rotation is talking about, if I put my pointer here, I start here, a rotation is going all the way around back to that point. Or if I started down here, going all the way around back down to that point. So instead of 60 rotations, I'm just looking at one rotation. So my period is how long it takes for one rotation. So if there's 60 rotations every second, the period, and I apologize, I don't have my iPad, so I'm writing with my mouse. It's a little harder here, but a period is going to be 1/60 seconds. So if it takes 1 second to go 60 rotations, it takes 1/60th of a second to go one rotation. Okay, we basically just flipped it. It was 60 over 1, and I flipped it to 1/60 for one rotation. And then it says point B, sorry, thought I had to sneeze. Point B is on the tip of one of the blades and is located directly above the center of the motor at t equals 0. So this point here is when the time is equal to 0. As indicated in the figure above, point B is 6 inches. So point B is 6 inches from the center of the motor. So if I label this, basically the radius of the blades is 6 inches. And then the center of the motor is 20 inches below the water line. As the blade of the motor rotate at a constant speed, the distance between B and the water line periodically increases and decreases. So this kind of tells you right here what exactly it's measuring. So the distance from B and the water line. So at this point, how far am I from the water line? At this point, how far am I from the water line? And then at the bottom, how far am I from the water line? So the periodic function models the distance between points B and the water line in inches as a function of time t in seconds. So what I'm always going to do here is label these points, like label the axes here. So right here, 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 and then the time values for each one of these, okay? That's how I'm going to go about doing this because that's going to make my points make a lot more sense. Because if you notice, point F is at my highest distance here. So point F has to start where my highest distance happens the first time. My point F happens when I'm at the farthest distance the first time. Because notice here, at point B, that can't be where point F is. Sometimes it is, but in this case, if I, 1 second, if I zoom in a little bit, if point B was down here, it would be, but point F is talking about the farthest distance here. So I have to start at my farthest distance. So basically when point B rotates to right here, so I've rotated to here, that's where point F is talking about because it's the farthest below I'm working at here. That's the farthest below I'm working at. So I have to start at my max height because the way the graph's set up is right here. This is going to be my max height, my middle height, and my lowest height, or my distances rather. So here at point F, if I am 20 inches to the center, it would be 20 inches here, and then 6 more because the radius. So my total distance here would be 26 inches. Okay, so the farthest I go down is 26 inches. If my blade rotates again and I'm right here, okay, you could think of that as point G. So once I rotate to the halfway point, I'm just 20 inches because that's what it says from the center of the motor to the water line. So this is 20. And we can label this as inches, 20 inches. And then if I rotate up again, right, my blade is 6 inches, like from the center, and it's 20 inches from the water line to the center. So 20 minus 6 here gives me 14 inches. Okay, so I have those labeled. So 14 inches. So at the lowest point, I'm 26. At the middle point, I'm 20. And then closest to the surface, I am 14 inches away. And now I've got to think about here. How exactly do I find my point here? Because I might be tempted to go down here. Oh, sorry. It's really scrolly. I might be tempted to say I start at 0 here. But that's not right. Because technically, my 0 point, it says t equals 0 at point B. So time equals 0 right here at the top. Time equals 0 at the top in this case. So I have to go a half period, because think about it. I went a half period to end up at point F here, right? I went a half period to go the farthest down the first time. I went a half period. So here I'm trying to think of half a period. And I already know here, that my period is 1 over 60. So this right here, I went half a period. So half of my period is going to be 1 over 120 seconds. So 1/120th. And what I do is go ahead and go a full another period to point P and then just do halfway points there. So I'm going to do F first, do P next. So if I'm at 1 over 120 and then I go a full period, I basically add. So to get here, I'm going to start at 1 over 120 and then add a period because I started at the top here and I end at the top here. So that's what a period means, right? So I add my period, which is 1 over 60. And then I do right here, you can rewrite that as 1 over 120 plus 2 over 120. Just getting that into common denominators. So I've got 3 over 120. And I think it's helpful to go ahead and write both this form, 3 over 120, and the simplified form. So this is also the same thing as 1 over 40. Okay, 1 over 40. But I like to have this unsimplified form here, in here, because halfway between 1 over 120 and 3 over 120, that's how I find J, because it's the halfway point. Halfway between 1 and 3 is 2 over 120, which is the same thing as 1 over 60. And then the halfway point between 1. So now to find G, I'm going to find the halfway point between here and here, which would be 1.5 over 120. but you're never going to have a fraction that has a decimal in it. So if I multiply the top and bottom by 2, that'll get rid of the fraction. So I have 3 over 240, okay, which simplifies to 3 over 240 simplifies to 1 over 180. And then the same thing here. Halfway between these will be 2.5 over 120, which is the same thing as 5 over 240, which does simplify, sorry. 5 over 240, 5 goes into 240 48 times, so 1 over 48. Okay, so now that I have my axes labeled, I can go ahead and label my points pretty easy here, because the bottom here, so my x coordinate for F is here, and my y coordinate is here. So from here to here, it's 120, comma 26. G is 1 over 80 and 20. I'll write this one in red. So right here, 1 over 60 and 14. Sorry for the handwriting here. I'm writing with my mouth best I can. K is going to be 1 over 48, comma 20. Oh, sorry. And then P right here is going to be 1 over 40, comma 26. So now we go to the other parts, and these are really the easier parts here. So I'm just going to erase these to get them out of my way here. Refer to the graph of H in part A. The t coordinate of K is T1. So this first part is like we're going from K, and the t coordinate of P is T2. So we're going from K to P right here. I'll highlight this in green, K to P. Okay. So the first question asks on the interval T1 to T2, so basically from K to P, which of the following is true about my height, my distance here? So notice H is talking about the values of H, right? It's talking about the values themselves of H. So H is talking about my distance here from the water level to the blade. So I'm going from 20 here to 26, which you can see right here. K is at 20, P is at 26. So from 20 to 26, all those values are going to be positive. So I know I can eliminate the negatives. And then are my values increasing or decreasing? You can see here I start at K and I go up to P. I go from 20 up to 26. So that is why the answer is A, increasing. And then on this last part, describe how the rate of change of H is changing on the interval. This is talking about concavity. So on this interval here, you can kind of see K is an inflection point. Originally I was concave down here, and then at K I flipped to concave up until this point right here. So on K to P here, this is part of a so this is concave up, this is concave down. I might have said that wrong the first time. So this part's concave up, and then at K I switched to concave down. So right here, this is concave down, just to make sure. This is concave down, and that's the first step. I'm just going to go ahead and write that. On the interval, a function appears to be concave down. So appears to be concave down. Oh, sorry, this mouse is so finicky. So it appears to be concave down here. So remember, down makes me think decreasing. So the rate of change of H is decreasing.